Alright, well, g'day everybody. Welcome to the next video on the linear function series. Today we're going to be chatting about the gradient intercept form of a line. So what is the gradient intercept form? Well, it's simply a way that we can write the equation of a linear function. And remember, the equation is just the rule that compares how those two variables relate to one another, how one changes according to the other one. So in this is our equation, y equals mx plus b. Now our only two variables there are our y and our x, whereas m stands for our gradient, okay, and that's a constant value, and b is our y-intercept, which also is a constant value. Now, as we've discussed in previous videos, you'll be aware that we don't have to necessarily have y and x as my variables. We can use anything we want, but they're the two different quantities that we're going to be comparing. A couple of notes that we can have about this, that if b is 0, we know that the equation actually just becomes y equals mx, which is often what we talk about in terms of direct proportionality. We looked at that in the previous video. That has the equation y equals mx. Now b, that means, therefore, shifts the line up and down. Now if you think about it, in this example right here, so I've drawn the line y equals x on 2. Now hopefully you guys can see that that's got a gradient of a half. It goes across 2 and it goes up 1, so a rise over run is a half. Also, the y-intercept is 0. When x is 0, you can see that it passes through 0. But what if I looked at the line y equals x on 2 plus 1? Now hopefully you guys can see that the gradient is the same. They both have a slope of a half. And if you think about two lines that have the same slope, they're actually going to be parallel. They have the same steepness. But what's happened to this one is we've added 1 to every single value of the y value. So from this point of view, you can see when x is 2, y is 1 on the first line. That means on this line, instead of y being 1, it's going to be 1 plus 1, which is going to be 2. In fact, every value on the line is going to be 1 bigger than the line below. You can hopefully also see the y-intercept is going to be 1, but it's going to be parallel 1 unit higher, so it's going to look something like that. Hopefully that's parallel. Always better to use a ruler. I can have one on me on this, and so I'm going to do it like that. But there is my equation, y equals x on 2 plus 1. I could also go y equals x on 2 minus 1, and that's the same line again, but it's just going to be shifted down 1. You can see, hopefully, that all these lines are parallel, they've got the same slope, but our y-intercept is changing. That one's passing through minus 1. Okay, so what do we need this formula for, this gradient intercept form? As I said, the equation of it, the beauty is that if we have the gradient and y-intercept of a linear function, then we can easily produce the equation for that line. So let's look at some examples. What is the gradient and y-intercept of the following? All right. So the first one, y equals 3x minus 1. That there is our m, or our gradient, and that there is our b, our y-intercept. So therefore, we can just say m equals 3, which is our gradient, and b equals minus 1. All right, so therefore our gradient equals 3, and our y-intercept equals minus 1. Next one. This time, you might be a bit confused about what's going on here, but another way we could write y equals minus x on 2, it's exactly the same as minus a half x. Okay, if you think about that, we can always write x as a fraction as x over 1, and so if I multiplied both those, it would end up the same. But you can also see that my y-intercept in this circumstance is actually 0. I'm adding nothing to it, and so therefore we can say that m equals minus a half, my gradient is minus a half, and b, or my y-intercept, equals 0. This one's a little bit more confusing because, hang on, it's not in the form of y equals mx plus b. You can see I've got all sorts of terms here on one side. So what we actually need to do in this, we need to have a little bit of an algebra bash. We need to manipulate this equation to make y the subject. We want to get y by itself. Okay, so we're going to do that by moving everything else to the other side. So let's go and do that. First step, I'm going to subtract 12x. So I'm going to get 3y minus 9 equals minus 12x. Then we'll add 9. So I get 3y equals minus 12x plus 9. Finally, we're going to divide everything by 3. And I get y equals minus 4x plus 3. And now, happy days, we've got it in the right form. And so that gives me gradient equals minus 4 And our y-intercept now equals positive 3. And that is that one. Something I will note about this question is this actual way of writing in terms of this, that's what we call general form. And general form is just a different way of writing a linear equation. A couple of special rules about it. We always say that the coefficient of x is positive. We say that there's no fractions, and we say that everything, all our terms are on one side, so it equals 0. We can have a look at that a little bit more later, but I just thought I'd note it there. The last one I've got here, similar to that question before, and I'll go through and solve it. We need to move everything to one side, so we need to move just our y's to one side. So I only need to shift this by adding 2y to both sides. So I'm going to get 3 plus 5x equals 5y here, and then we'll divide everything by 5. I'm just going to switch sides for it. So I'm going to get y equals x plus 3 over 5. And so, what is my gradient? Well, my gradient is the number in front of x here. So m equals 1. Doesn't equal 0, there's 1x there. And also, b equals 3 over 5. Don't get scared if anything's a fraction, it still works. Alright, let's finish by sketching these linear functions. So y equals x minus 1. From what we know, we can see our gradient equals 1 and our y-intercept equals minus 1. So it's going up, our rise over run, a slope of 1. For every 1 it goes across, it goes up 1. And it passes through negative 1. So it's going to look something like that. Alright, so my y-intercept is minus 1. And every 1 it goes across, it goes up 1. So if you want to think about it like this, it goes across 1, goes up 1. In fact, it means that my x-intercept is going to be 1 as well. Always make sure we write in that equation, y equals x minus 1. Last one here, need to rearrange it first. So let's get y by itself. I'm going to move the other things. So I'm going to get 2y equals minus 4x plus 1. Divide by 2, y equals minus 2x plus a half. So therefore I know that my gradient is minus 2 and my y-intercept equals a half. So we know we're going down. For every 1 we go across, we're going down 2. And we're starting at minus a half. Sorry, starting at positive a half. It's my y-intercept. So we'll draw that one in. It's going to look something like that. Put that in there. So that's going at a half. Can be good just to show our x-intercept. So when y equals 0, if you rearrange that equation, we're going to get x equals a quarter. Alright, so that's actually equaling a quarter there. I'm zoomed in pretty close. And so that gives me the equation 4x plus 2y minus 1 equals 0. And that is linear functions for you in gradient intercept form. Good luck with it.